Today we are going to learn about optimizing performance with Python List Comprehensions. We will explore techniques to enhance code efficiency and readability using list comprehensions. Welcome to our video on optimizing performance with Python List Comprehensions. In this session, we'll explore how list comprehensions can significantly enhance the performance and readability of your Python code. List comprehensions offer a concise way to create lists, outperforming traditional loops in both speed and clarity. Today, we'll delve into the advantages of list comprehensions, identify when and where to use them, and explore strategies to avoid unnecessary computations, employ conditional logic, and handle large datasets efficiently. By the end of this video, you'll be equipped with the skills to implement list comprehensions effectively in your projects. List comprehensions offer several advantages over traditional loops. First and foremost is performance. List comprehensions are typically faster than loops because they are optimized for Python's internal implementation. This speed boost can be particularly significant when dealing with large datasets. Another key advantage is readability. A well-written list comprehension can express complex operations in a single, concise line of code, reducing clutter and making your scripts easier to understand and maintain. Moreover, fewer lines of code mean fewer opportunities for errors, which can improve the overall robustness of your programs. The syntax of list comprehensions is straightforward and intuitive, making it easy to iterate over iterable objects like lists, strings, or ranges. This direct iteration means you can perform operations directly on each item in the iterable without needing to manually manage loop counters or indices, which can further streamline your code.
Knowing when to use list comprehensions is crucial for optimizing performance. They're ideal for simple transformations, where you need to create a new list by applying a simple operation to each element of an existing iterable. Filtering is another common use case. You can easily include a condition to select only the elements that satisfy a particular criterion. However, caution is needed when dealing with nested loops. While it's possible to use list comprehensions for nested loops, the resulting code can become hard to read and maintain. In such cases, it might be better to stick with traditional loops. List comprehensions can also replace map and filter functions, offering a more Pythonic way to perform these operations in a single line of code. However, they should not be used when the operation involves complex logic or side effects, as this can make the code difficult to understand and debug. In such scenarios, traditional loops or functions may be more appropriate.
One of the keys to optimizing performance with list comprehensions is avoiding unnecessary computations. This means minimizing redundant operations and ensuring that each computation contributes to the final result. In situations where you only need to iterate over the results once, consider using a generator expression instead of a list comprehension. Generators provide memory efficiency by yielding items one at a time rather than generating the entire list at once, which can be particularly beneficial for large datasets. This lazy evaluation approach ensures that computations are only performed when needed, avoiding the overhead of computing values that are never used. Profiling your code can help identify opportunities for optimization by revealing bottlenecks and unnecessary computations. By focusing on these areas, you can make targeted improvements that enhance the overall performance of your code.
Conditional logic is a powerful addition to list comprehensions that can help simplify complex filtering tasks. By incorporating conditions directly within the comprehension, you can create lists that include only the elements that meet specific criteria, enhancing both the performance and readability of your code. This approach is particularly useful for simplifying complex filtering logic that might otherwise require multiple lines of code and nested loops. However, it's important to avoid deeply nested logic within a single comprehension, as this can reduce readability and increase the potential for errors. Instead, aim to keep the logic clear and straightforward, using list comprehensions for both inclusions and exclusions as needed. By leveraging conditional logic effectively, you can create clean, efficient code that is easy to read and maintain.
Handling large datasets efficiently is a common challenge in Python programming, but list comprehensions can offer some solutions. To optimize memory usage, consider using generator expressions instead of list comprehensions when you only need to process the data once. Generators can yield results one at a time, which significantly reduces memory consumption compared to loading the entire dataset into memory at once. For extremely large datasets, chunk processing can be a valuable strategy. This involves processing the data in smaller, manageable chunks rather than all at once, allowing you to work within memory constraints. Avoid loading entire datasets into memory when possible, and use streaming or batch processing techniques to handle data incrementally. Profiling and benchmarking your code can help ensure scalability and identify potential performance bottlenecks. By implementing these strategies, you can manage large datasets effectively without compromising performance.
Incorporating Python's built-in functions into your list comprehensions can greatly enhance performance and readability. Functions like map and filter are optimized for speed and can perform common tasks more efficiently than custom logic. For more advanced operations, the itertools module offers a variety of tools that can be combined with list comprehensions to achieve complex results with minimal code. Using built-in functions not only optimizes performance but also reduces the need for custom logic, which can simplify your code and make it more maintainable. By leveraging these functions, you can create efficient, readable code that takes full advantage of Python's capabilities. Profiling and benchmarking are essential for understanding the performance of your list comprehensions and identifying areas for optimization. Tools like the TimeIte module can provide precise measurements of execution time, allowing you to compare the performance of list comprehensions against traditional loops. Meanwhile, the cProfile module offers insights into function call times and can help identify performance bottlenecks in your code. Analyzing memory usage is equally important, particularly when working with large datasets. By combining these tools, you can gain a comprehensive understanding of how your list comprehensions perform and make informed decisions about where to focus your optimization efforts. This process not only enhances the efficiency of your code but also ensures that it scales effectively as your applications grow.
In this section, we'll explore several case studies that showcase the performance improvements achievable with list comprehensions. These real-world examples illustrate how developers have transformed their code by replacing traditional loops with list comprehensions, achieving significant gains in both speed and readability. We'll examine the code before and after optimization, highlighting the specific changes made and the resulting performance benefits. Additionally, we'll discuss the lessons learned from these case studies and identify best practices for implementing list comprehensions in future projects. By learning from these examples, you can apply similar strategies to your own code, achieving optimal performance and efficiency. As we conclude this video on optimizing performance with Python list comprehensions, let's recap the key concepts we've covered. We've explored the advantages of list comprehensions over traditional loops, identified when to use them, and discussed strategies to avoid unnecessary computations. We've also examined the use of conditional logic, handling large datasets, and incorporating built-in functions for speed. Profiling and benchmarking your code are essential steps in understanding performance and identifying areas for improvement. We hope this video has provided you with valuable insights and practical skills to enhance the efficiency of your Python code. Thank you for watching, and we encourage you to practice these techniques in your own projects. Consider further learning to deepen your understanding of Python optimization.